In the surge software, it is recommended that a closed surge tank is first added to the model and sized so that it successfully addresses any transients in the model. See also the Tips and Topics video called Adding and Sizing a Surge Tank. We will take the information from the closed surge tank analysis and use that for sizing a bladder tank. In particular, we need the bladder precharge pressure in order to use a bladder tank in the model. Remember that a handy device help screen is available under this icon. The device help provides references to units, definitions, and geometry. And here we see the input for preset head, which we need to know in order to model a bladder surge tank. We will assume we have already added a closed tank to the model and we run an analysis and we're happy with its performance. In order to replace this closed surge tank with a bladder tank, we first need to collect some key data from the analysis results with the closed surge tank in place. First, we need the steady state head in the pipeline. Look at the results for pressure for the tank at time equals 0 seconds. We can click on the A result icon to display results in the node info window. We have both pressure results and head results. We'll write these both down for reference with the bladder surge tank sizing tool, which we'll talk about in a minute. Next, look at the volume results for the surge tank. We want to find the maximum gas volume. I suggest viewing the graph first. Turning on volume results. We can estimate the maximum volume from this graph. If you want to get a more exact value, go to the time about which this maximum occurs, around 40 seconds, and find the maximum value in that table. So we see that we have a lot of 34 values, so we're rounding to an integer. One thing we can do to get more precision in our result is to go to the Appearance tab, Precision menu, select Volume, and increase the number of decimal places. Now when we look at this table of results, we see much more detailed values. We can safely assume that our maximum volume is 33.94 cubic meters. Now we will launch the Bladder Precharge tool. It's found under the Tools menu. There is some help available for the tool which discusses the steps we are taking in this video, in addition to some discussion about how the gas volume is calculated. We'll skip the help for now. And here is the tool. You can select different units for volume and pressure. We'll accept the defaults for now. For the tank bladder volume, we want to use the max volume data we collected. I recommend increasing the value slightly so the bladder tank won't be undersized. Our value was 33.94 cubic meters. So let's use a value of about 37 cubic meters, which is roughly 10% larger. Next, enter the initial air pressure, which in this case we're entering it in meters of head. Our value for the initial line pressure that we measured earlier was 76.9 meters of head. The initial air volume is the initial gas volume which was input for the closed surge tank. This value can also be adjusted slightly as long as the value is similar to the initial input for the closed tank, such as 50% of the tank volume. Our initial air volume was 15. We now have a precharge pressure, which is 25.03. We can change the closed surge tank to a bladder tank in the device type selector. All of the inputs need to be checked. Our tank volume is going to be 37, and we want to enter our new preset head, which was 25.03 meters, and it is in head. If you wanted to enter this value in pressure, you could check this box to use pressure. We're going to leave it unchecked for now. Now the hope is that when we run this analysis, the results will be very similar to the closed surge tank. Pull up the graph, show previous results, and we can see that the two results are very similar, and that this is a good substitution of a bladder tank for a closed surge tank.